Hi guys, we're here with lesson 3-4. This is video 1, solving by elimination. You've been looking at different strategies for solving systems of equations. This is the third and last one that we're going to look at, and it's called solving by elimination. So what we're going to do in this is we're going to refer back to several of the things that you already know, like you already know how to solve simple linear equations like this one right here. We have 3x plus 5y is equal to 10. You know, you can add or subtract the same quantity from both sides and you will preserve the equality that's there. You can also multiply or divide something by the same side and you still preserve equality. So these ideas are called the properties of equality. We looked at those in back in lesson 2, so you can go back and look at those properties, but it just says basically, you know, whatever operation you do to one side, you do to the other side, so the two sides remain equal. Therefore, the properties of equality, what makes things remain equal. So we're going to solve systems of equations using these properties of equality by combining these two separate linear equations together through our basic operations of multiplying, adding, subtracting, and those kind of things. But when we combine them together, we're going to eliminate one of the variables. So we often call this method either the elimination method or the combination method. You'll hear both. So don't be surprised with either one that you hear. I often call it the elimination method. But what we're doing is we're combining. So let's look at our example that we have right here. Okay, we'll start with the first one. Okay, we have two equations. They're lined up. The x's are lined up, the y's are lined up, and the constants are lined up along with the equal signs there. So what we're going to do is we're going to combine these two equations in a way that one of the variables will eliminate so that we can easily solve the equation. And if we look at the one that we have here, the first one, we really don't have to do much to make this happen. All we got to do is just add these two equations together. When we add them together, the x's, there's a positive 1x and a negative, not the x's, the y's. There's a positive 1y and a negative 1y. When you add those together, they go to 0 or they eliminate. So this is what we want to happen. We want one of the variables to eliminate. So we'll add our x's together. So 1 plus 1, that would be 2x. And then we have a positive 1 minus 1. Well, that's 0. So 0y you don't have to write down. That would be kind of redundant. And then you have your equal sign, and then 3 minus 9. 3 minus 9 is negative 6. So you're going to look at that, and wow, that cricket is really loud. I don't know if you just heard that or not. But now one of the variables has eliminated, so we can solve for what x is. So we need to get x by itself. 2 is being multiplied, so we would divide by 2. And we would have x would be equal to negative 3. Now, we need the solution. The solution would require that we know what the x and the y is. So we've got an x value. Now we need to know what the y value is. So I'm going to take this x and I'm going to plug it back into my first equation. You can really plug it into either one, but I tend to always go back up into the first one. But if one looks easier than the other one, plug it in that one. So we'll plug it in. I'll switch colors so we can kind of see what we're doing separately. So we got x is equal to 3. We're going to plug it in that original equation before we do anything to it. So x would be negative 3 plus y is equal to 3. So now we're going to solve for y. So we're going to add 3 to both sides. And y would be equal to 6. So I think my answer to my equation is x is negative 3 and y is 6. I always want to check and make sure my answer is correct because I could have made any number of mistakes through here. So we're going to plug it back. We already plugged it into the first one, so we're going to plug it into the second one and see if we get a true statement. So we would have a negative 3. So this is my check. We're trying to make sure my answer is truly right. We're plugged it in this one, so we're going to plug in this value right here. So we'd have negative 3 minus 6 should equal to negative 9. Is that true? Yes, that's negative 9 equals to negative 9. So it worked in the bottom equation. We'll just double check and make sure it really does work in the top equation. Negative 3 plus 6 is equal to 3. When I add those together, 3 is equal to 3. It's true for both solutions, both equations, excuse me. So we'll put a box around that because that is the solution to the systems. It is a solution to both of them. Okay, so let's look at another one. Here, you can see that the x's, it doesn't matter whether the x's cancel or the y's cancel. It doesn't make any difference. If I add my like terms together here, a positive 3 and a negative 3, when you add that together, it goes to 0x. You don't have to write down 0x. You can just say they go to 0, and you don't write down 0. And then you got 5. It's got the understood 1 on this one. So you got 5 minus 1 is 4y. And on the other side of the equal sign, you have 8 minus 4, which is 4. So when you solve for y, divide by 4 to get rid of the 4. And my y value is 1. So if my y value is 1, then I'm going to plug it in to my top equation up here and figure out what my x value is. You can plug it into either one you want. I just always tend to go to the first one, like I said. So I'm going to plug this y in right here for my y. So I would have 3x plus 5 times 1 is equal to 8. So that's 3x plus 5 is equal to 8. So when you solve, you're going to get rid of your 5 by subtracting 5 from both sides. So 3x would be equal to 3. Then you'll divide by 3. And you will have x is equal to 1. So I think my solution is x is equal to 1, y is equal to 1. But I want to make sure that I didn't make any mistakes. I want to make sure that I did this correctly. So I'm going to check my work right here. Well, my pen's not working. Okay. And it should work in both of the equations. So I'll plug it in the bottom one. Negative 3 times 1 minus 1. Hopefully that equals to negative 4. So negative 3 times 1 is a negative 3 minus 1. Well, that is negative 4. So these two things are equal to each other. So it worked for the bottom equation. Now we'll plug it into the top one just to make sure that it works in that one also. So we have 3 times 1 plus 5 times 1. It better equal 8. So that's 3 plus 5, and that equals 8. And that's what we said that it should equal up here. See if I can squeeze that in there. And it does. So it was the solution for the bottom one and for the top one. So we'll put a box around that to show that that is the solution for the systems. On the next slide, we have 2 for you to try. So pause for just a moment, work those 2 you tries, check your answers, make sure that you're getting it right. You should be able to do that with a calculator without even having to go up and look at your solution guides. Okay, I'm going to pause now.